So you are going to be introducing the MVVM Toolkit, a .NET Standard library in the Windows Community Toolkit, aren't you? So I know that we're tight on time, so I'm just going to let both of you take it away, and you can introduce yourselves. Yeah, best of
Perfect.
luck.
Awesome.
Thanks. Great. So as Leila said, thanks. We're introducing the MVVM Toolkit, which is a .NET Standard library in the Windows Community Toolkit. And I am Michael A. Hawker. I'm also known as the XAML Llama, which is why I have this hat. I am a senior software engineer at Microsoft. I am also the maintainer of the Windows Community Toolkit, which we'll talk a little bit about in a moment. I also created an app called XAML Studio, which is a Microsoft Garage project, which you might have heard of. And with me is one of our community members.
Hi, everyone. My name is Sergio Pedri. I'm a computer engineering student and a member of the .NET Foundation and the Windows Community Toolkit org. I'm the author and maintainer of the MVVM Toolkit, which we're presenting today, as well as the High Performance package, which is another package in the Windows Community Toolkit. I'm also a UWP developer and the author of Ledger and OneLocker, which are two UWP applications in the Microsoft Store.
So for this presentation, we're going to quickly give you an introduction to the Windows Community Toolkit and what that's all about. And then, of course, we are going to move right into our MVVM Toolkit and telling you and sharing about what all this greatness is that you can start using in your apps. Sergio is going to give a lot of time for the demo today to dive into our sample app and show you all the different code bits that you can use with this library. And then at the very end, we're going to have our question and answer period, so you can use the hashtag .NETConf and MVVM Toolkit on Twitter to send us questions that we can go over at the end there. So the Windows Community Toolkit is a suite of controls, extensions, and helpers for Windows development. Though we're not just for UWP developers, we have a lot of more .NET Standard libraries as well now, such as the MVVM Toolkit we're going to be talking about today. We are part of the .NET Foundation. We're MIT licensed, and all our code is up on GitHub, open sourced. We do all of our work there and planning and everything, so you can come and join us along there. We've had over 25 releases in the last 4 years. We've closed over 1,000 issues, have had millions of NuGet package downloads with many, many commits by hundreds of contributors. So we really enjoy working with everyone and building lots of great stuff there. And if you want to see what we have to offer, we actually have a sample app that you can download from the Microsoft Store. That's available at aka.ms/Windows Toolkit app. There's documentation in the app. We have a playground for each control and helper. You can even live edit the XAML in the application to try things out before you put that, bring everything into Visual Studio. And we actually have a new contribution guide. So once you've kind of played with things and built your own apps with them, if you want to actually give back to our project and the community, you can find our new wiki at aka.ms/WCT/wiki. And it goes into all the details about how we run the project, how to make a contribution, and details about how we actually build the toolkit and put everything together.
All right, so here we're going to assume that all of you are already familiar with the basics of the MVVM architecture. But just to make sure we're on the same page, we can do a small recap here. So the MVVM architecture is a software architectural pattern that can be used to develop applications, primarily to separate concerns. The name itself, MVVM, stands for these three main components that you can see here: the model, the view, and the view model. The model represents the application domain of an application, and it contains all the various data items that an application needs to work with. The view is the framework-specific layer, and it contains all the various UI elements and controls that the user directly interacts with. And lastly, we have the view model, which is the layer that sits in between these two, and that enables communication between them using commands, bindings, and more. Now, what are the actual benefits of the MVVM pattern? So first, we have the fact that it makes it particularly easy to reuse code across different platforms. So you might imagine having the entirety of your backend as a separate .NET Standard or .NET 5 project, and then you would only need to re-implement the various UI layers and platform-specific services if you have any, while at the same time reusing all your backend without any code changes. This is also made possible because the MVVM architecture has the entirety of the backend completely decoupled from platform agnostic behavior. So if you do rely on specific platform APIs, you can just typically abstract them away and then inject them through services. This also makes the actual testing quite easy, since you don't need to have platform-specific dependencies while doing unit testing. And if you actually need some platform-specific APIs, you would be able to mock them and then inject them as mock services, for instance. The MVVM architecture also helps with the separation of design and development, since, as we said, the UI layer would be completely decoupled from the actual backend and the business logic of an application.
So with that, it's our great pleasure to introduce the MVVM Toolkit to you. It's a modern, fast, and modular MVVM library that is part of our Windows Community Toolkit, but is .NET standard based, so it can work for whatever apps you're trying to build, be it UWP, WPF, Xamarin, Blazor, Uno, all those different types of great apps that you can build. We can use this library with. We really want it to be simple to pick up and use, and kind of be able to pick any different piece of the library that you want to use within your app. We don't kind of really dictate any large structures. Of course, you're using the MVVM pattern, but if you want to use a small subset of the library, you can do that, or you can use everything that's there. It's really up to you. It's really meant to be a reference implementation, something that is implementing all the interfaces that are alluded to in the base class library, and things that you would expect to need for building with the MVVM pattern. And so, of course, we get the question, why are we building a new MVVM library now? The main kind of instigators are MVVM Lite and now Calibre and Micro are no longer being maintained. And MVVM's Lite simplicity was really kind of embraced by the community and was going to be missed. So we really started this discussion our community started this discussion with us back earlier this year. And really we took inspiration from MVVM Lite by Laurent Bugnon, and I saw that he was in chat, so I think he's still around. And so we really kind of worked with him and others in the community to really kind of take this project to light and bring it forward, and really kind of keep that simplicity, but provide that really strong base and a great home for it to live for the future, and really take advantage of a lot of the advancements that have happened in .NET development and application development since a lot of frameworks have been built, really targeted, looking at the problem all up and optimizing for CPU and memory usage. And so you can see that with some benchmarks here we did on our Messenger publish subscribe class here, comparing to our predecessors of MVVM Lite and Calibre and Micro. We really kind of get 5 to 14 times faster performance with hundreds of times less memory, or if you use the strong reference that Sergio is going to talk about a little bit later, you can even get 0 allocation for memory for broadcast messages.
All right, so here we can see how the actual MVVM toolkit is structured. So the MVVM toolkit is composed of a number of building blocks that are organized around these 4 main categories that you can see here. The idea is that for the most part, all of the various APIs in these 4 categories would not rely on any of the other APIs in the other categories. So this makes it very easy for you to just pick up and choose the individual components that you need without being forced into necessarily having to use all of them. So this is one of the actual core principles that we use to build the MVVM toolkit from the start, as Michael mentioned. So here we can see these 4 main categories that relate to things such as relaying property change notifications, commands, message broadcasting, and inversion of control. And we can see more about all of these during the demo. So for that, let me actually switch to the sample app that we have. So this is a sample application that we built to showcase all of these various APIs that we include in the MVVM toolkit. This application is itself built using the MVVM toolkit, and that powers all the actual backend and all the various view models that we have here. The application in this one in particular is running on UWP, but we also have a version of this that runs on Android, macOS, iOS, and also WASM through Uno platform, using the same code using the same backend that we have here. So to quickly go through the main category, starting from the observable object class. So this is a reference implementation that we offer for the unnotified property change interface. This is an interface that's part of the base class library, but that lacks a concrete implementation there, which we're instead providing here. This interface is crucially important for the MVVM architecture, since it's the one that actually powers all the notification logic for properties that are being monitored by UI components, so that they can react dynamically and in real time as the value of this property are changed. So here we can see an example of how you would use the various APIs exposed by this type to implement observable properties. So here, for instance, we want to implement a property that we call a name. It's of type string. And then here we're in the setter, we're invoking this set property method that's inherited by the observable object class. And then in this case, we're using an overload that takes a reference to the backing field and then the new value of the property. And then this method will take care for us of checking whether or not the value of the property has changed. If so, it will assign to the target field, and then it will also automatically raise all the various necessary events to notify the UI components. Here we have an interactive sample where we can see we have a view model with this simple property. In XAML here we have a text box that binds two ways to the name property so that it's updated whenever we type. And then we have a text block that binds to the same name property. And here in the sample you can see that as I start typing, like please pay test, the value of the text block is updated dynamically as I type. And all of this is done in simply one line of code in code behind. Next, I want to mention this new set property notify on completion method that we offer. This is an extension of the set property method that I just mentioned, but this one in particular is meant to be used to help out in scenarios where you have properties that are of type task. So in this case, what this method will do, it will do exactly what set property did. So it will check whether or not the value has changed, and if so, it will raise the events. But in addition to that, it will also start monitoring the task so that when it completes, it will also raise the necessary events again so that the UI components will be notified again when an asynchronous operation completes. This is actually a very useful building blocks when working with asynchronous operations, and all the other asynchronous APIs that we include often use this building block internally as well. Here we have an interactive sample for that. In this case, we have a view model with a simple property, which is of type task. In the setter, we're using the set property notify on completion method, and we're passing a reference to the backing field, which is in this case of type task notifier, which is a type that we expose from the observable object class. And then we're passing the new value of the property, which in this case is the result is being set here. So it's a task that's the result of a delay of 3 seconds. Here in XAML, we can see that we have a button that simply invokes the method, and then we have a text block that simply binds to the status of the task. So you can see from here that we're binding directly to the property of the task without the need for extra objects that act as wrappers around the task instance. And here we can see in the sample that as I click the button, we display the initial status of the task. And then when it completes, the property change events are raised again so that the UI can dynamically react to them. Moving to the second category, which includes our command types. So this first category includes the relay command and relay command of T classes, which are two reference implementation, again, for the iCommand interface, which is another interface that's part of the base class library. In this case, this can be used to abstract methods that sit in the view models so that the UI component can bind to them in a loosely coupled fashion. So here we have a sample where we have a counter property here that's observable. We have a private method that simply increments the counter. And then here we want to wrap this method here. So we create a new relay command instance wrapping this target method. In this case, we're using the method group syntax to create a delegate that maps to this method. And then we're assigning that to this iCommand property here. And here in XAML, we have a button that directly binds its command property to the command that we have in the view model. And then we have a text block that displays the value of the counter. And here in the sample, you can see that as I click the button will invoke the command will invoke the method it's bound to, and that will increment the counter, which will raise the notification events that will be reflected in the UI. So all of this is done with just 2 lines of code to declare and initialize the command, and then just 1 line here for the setter to inject the notification logic for the property. Next, we also have 2 new types of commands that are meant to be used to help with asynchronous operations. So this is something that was typically quite verbose to do in the past, since you would have to manually track the task being returned by your asynchronous operation. So you would have to often manually declare properties to monitor whether or not a given operation was still in progress. You would also, if you wanted, for instance, to support cancellation, you would have to manually track cancellation tokens being passed around. So here instead, we're offering these 2 asynchronous command types that are meant to help with all of this and that are meant to do all of this heavy lifting for you. So here we can see how that works. We have this download text async method that simply waits 3 seconds and then returns this hello world string. We're wrapping this using creating a new instance of this async relay command here, which we are assigning to this property, which is of type async relay command. And here in XAML, we have a button that again binds its command property to the command that we declared in the view model. We have a progress ring that in this case binds its isActive property to the isRunning property that's exposed by the async relay command interface. And then here we also want to display the status of the task as well as the result of the task, in this case using a converter. We can see how this all works in practice. As I click the button, the progress ring starts spinning. We display the initial status of the task. And then when the operation completes, the progress ring goes away automatically. The status is refreshed, and we also see the result of the operation. So all of this heavy lifting is done with, again, just 2 lines of code in code behind. Next, we have the messenger types. So these are helper types that can be used to exchange messages across different modules of an application in a loosely coupled fashion. There are actually a number of steps that are required to get started using these types, and you can learn more about these in the docs or in our source code, but to just give a quick overview of how that works. So the first thing you would do would be to either declare a custom message type like we're doing here, or to use one of the base message types that we include in the MVVM toolkit. Next, you would need to register a recipient so that it would invoke some code when a message of that type is received. In this case, we're invoking register here. We're registering this instance as the recipient. We indicate that we want to listen for messages of this type. And in this case here, we're using a Lambda expression to define the code that will be invoked whenever this recipient receives an instance of that message. Then we need to broadcast a new message. So to do that, we invoke the send method here by passing a new instance of this message type. Here we have another interactive sample to showcase how this works. Here we have a sender view model that has a username property that simply toggles between Bob and Alice. And every time it does so, it also broadcasts a new instance of this username change message with the new value of the property. And then that message type is received by the second view model that you can see here is registering handler for this message type, and whenever a message is received, it will grab the value from the message and use that to update the local username property so that it's kept in sync with the one from the other view model. And here in the sample, you can see that as I click the button, the first module, which is this one here, will toggle the property between Bob and Alice. At the same time, it will send a message that will be received by the second module, which will read the value to update the local value of the property. Lastly, we also have a section about inversion of control. So in this case, we decided not to include code to actually implement a service provider in our library, since we figured there are already quite a few very commonly used libraries that are meant to do specifically this, such as the Microsoft Extensions Dependency Injection Library. So instead, we're offering a simple IOC class, which is a wrapper around the iService provider interface, and that's primarily meant to be used as a helper for developers either using the service locator pattern or for developers that are migrating from MVVM Lite, which had this specific type. But we'll also be offering docs that showcase how you can get started with either using the service locator pattern or the dependency injection pattern. So you'll be free to choose whatever approach you think works best in your specific scenario. Lastly, here we also have a small step-by-step guide that showcases how you can go about putting together all these various building blocks into an actual small working example. So in this case here, we have doc that showcase how to set up the various view models, how to define services, including platform-specific ones. Here we have a service that uses REST APIs. We have docs that showcase how to build the various UI component to bind to the backend. And then here we have a final working sample. In this case, it's a very simple Reddit browser that simply lets you load posts from a collection of subreddits you can choose from, and then whenever you click on a post, a message is broadcast to the second module, which will display the title, the image, and then a sample text. So then to go back to the actual presentation, I want to call out that there are a number of exclusive features that are included in the MVVM toolkit. So you can learn more about them by reading our source code on GitHub or our docs, but just to name some of them. So the first one would be that we offer built-in support for writing view models that wrap objects that themselves do not implement the iNotify property change interface. So basically, you would have an overload of the set property method that will allow you to inject the notification logic on top of that in just one line of code. Next, we have the set property notify on completion method, which I mentioned during the demo. And for this, I want to thank the .NET Native team that helped us both design the final API service that would ship, as well as testing the actual code to make sure it worked fine on both UWP and on the .NET Native runtime as well in particular. We also wrote a blog post about this if you're interested, and that's linked in our docs. Next, we have a new observable validator class that implements the iNotify data error info interface. And for this, I want to thank the WinUI team that helped us with the initial implementation of this type, as well as with code review during development. We also have these two new asynchronous relay command types that also support cancellation that I went through during the demo. We have a new strong reference messenger type that Michael mentioned. This is basically an optional messenger type that exposes the same API surface as the default one, which uses weak references, and that's basically acts the same way as the one from MVVM Lite and Calibre Micro. But this one is specifically meant for application that heavily relies on having a huge number of messages being exchanged at all times. So these strong reference message types requires some extra care, as it requires you to manually unregister recipients when you no longer need them. But in exchange for that, it's over twice as fast, and in particular offers non-allocation for broadcast operations. So it lets you send even millions of messages without allocating even a single byte of memory. Lastly, we also support multiple ways of actually declaring message handlers. So you can do that either manually through a Lambda expression, which is the same that you would do in MVVM Lite, or you can do that by implementing the iRecipient interface, and then which is basically the same approach that was used in Calibre Micro. So we support both, and you're just free to pick the one that you think works best for you, or the one that you feel the most comfortable working with.
Great, thanks, Sergio. And of course, the great news is that you can download our preview today at aka.ms/MVVM Toolkit. That is the link to our sample and doc repo, which has all the demo that Sergio showed you and info about how to get started. The packages are up on NuGet. It's really great to see the sample app itself being built with the toolkit. We already have an Uno sample that's in the works. We have seen people in the community creating samples and working with the toolkit in their own projects for WPF and for Blazor. And so we really kind of want to reach out to some folks and would love some help in those other technologies to have official samples within our structure as well. So that's something that we want to work on. We will ship this officially as part of our 7.0 release of the Windows Community Toolkit. That should hopefully be coming in the next month. We haven't quite nailed down the date for this year yet. If it doesn't happen before Christmas, it'll happen first thing in 2021. We've also been working with the Windows Template Studio folks. They have an issue open there to track integrating the MVVM toolkit into their templates to replace the libraries that are no longer maintained. So now it's time for our Q&A. So you can tweet and use the hashtag .NETConf and hashtag MVVM Toolkit. You can also follow myself at Zamalama and Sergio at Sergio Pedri if you have any other questions or want to engage with us in the future. And we will bring Layla back and answer some of your questions.
Hey, Sergio and Michael, thank you so much for that. It was really great to see. We've had some questions, of course. We've had El Buño answering a lot of the questions, though, so he's beaten you to it. But so I do have one on Twitter. I'm going to read it so we can see your lovely faces on here and not go to my desktop share. So the first one here is, does the MVVM toolkit contain means for screen composition and screen activation or deactivation? If not, are you planning to add something for it?
Michael, do you want to take that, or should I?
Oh, I was hoping you'd take that. That was a tricky one. I mean, so we're trying to be framework agnostic. So we're really trying to focus on the core elements that are built into C# or .NET rather, and really be platform agnostic. So we're not thinking a lot about the direct kind of helpers or anything for specific UI patterns or kind of transitions. Like we don't have like a navigation service built in or anything like that. We're giving you that kind of those bare bones building blocks that you can use to build up your view models and make those all .NET standard so that they can be used regardless of whatever UI framework you're using. Is that a good summary, Sergio?
Yep. Perfect.
Yeah, great. I mean, we totally expect people to build upon this maybe and even build other libraries that they could potentially add some of those framework types of components for specific things like WPF or UWP or Blazor, etc.
So I think, here we go. We have another one. I managed to share my screen and keep us all here, so that's good.
Yay.
So we have from Alan Natalini, great presentation by Sergio Pedri about WCT MVVM, and just a thank you, which is what I'm going to say as well, because that was great, and I really appreciate it. So it's been great to have you both on. So Michael, I think you can probably go to bed now. What time is it for you? About 2:30 in the morning?
Yeah.
Well, thank you so much for staying up late to be with us. And Sergio, you're in Rome, so you're ready for a coffee. Yep. Well, I really appreciate you both coming in and talking to us all. And I think, I found one more question on the Twitch chat. Oxfitty69, it's for .NET Standard 2.0. Is it compatible with .NET 5? That's the last question.
Absolutely. So at the moment, it's we're multi-targeting .NET Standard 2.0 and 2.1 in particular, so that we can use some specific APIs for some internal implementation to optimize things, specifically for the weak messenger type that on .NET Standard 2.1 uses the conditional weak table and other details. And we do plan to also look into multi-targeting .NET 5 to add some specific features in the future. But regardless of that, if you're using .NET 5, you will be able to just use the library as is, and it will pick automatically the .NET Standard 2.1 target, and it will work just fine. So yeah, absolutely.
That's great. Well, that's all the questions we have time for. If you have more questions for Michael and Sergio, make sure that you tag them on Twitter, and you'll get to them when you wake up, won't you, Michael? And Sergio, you might get to them this afternoon. So without any further ado, thank you so much, both of you. Have a great rest of your day, middle of the night, and thank you so much. So bye.
Thanks, Layla.